Now these, we have talked about charging some time back, not once, not twice. This is a charging subboard. This is a daughter board, a subboard. This is the connector. Please move it across, move it slowly by slowly. You can see it, it is dirty. Try to magnify it. Ndani kabisa tuone kama itaweza. Ionekane yote. You just move it. This is just a charging port, and as you have seen, from 240 to 5 volts, 5 volts will be entering this one. You move the charging port here, there. This is the charging port, but this is just the other side. This is a typical charging plate. It is dirty. Please clean it up. Brush kidogo yashe. Clean it up, clean it up. These are Huawei charging plates, and there are two ways of, if you want to measure such isafishia hapo ndani ya hiyo kamera, as in pale itaonekana safia tu kidogo tu, iwe safi kidogo. Kwa charging port hiyo ni safi sasa, vizuri sana. Sasa osha charging port mbele na nyuma. Yeah, alright. Hiyo side nyingine. Tosha. We shall tutakaa hapo kwanza. We shall remain there. This is a charging port. This is a Huawei charging port. Oh, while I explained about charging port the other time, there's something that I did not touch on. With this charging port, there are different kinds of tips. The one that is closest, adjacent to the upper part. Okay, you cannot see it this way. Let me try and magnify this. You see that tip, and this is the front side of the charging plate. You see the tip is on the lower side. Let me try to explain that one using another charging plate where the charger connects it. That plastic section where the charger, the plastic section with the pins where the charger connects with the port is on the lower side. This is the front facing side, but with this other charging port that I'm putting right now, you can see the plastic section, this part here in the middle is on the upper side. This is the front facing side of the charging plate, and you can compare with this one. One is on the upper side, the lower is, the other one is on the lower side. The one that looks like a tongue, this is what I'm talking about. I'm talking of this one here versus this one. You can see this one is on the lower section, this one is on the upper part. This is the front facing side of the charging plate. Be very careful. This charging ports can enter either. This one can fit here, this one, the other one can fit here. You can just interchange them. But if you interchange them, you might be you will not get the correct charging value, because one, you will have reversed the charging polarity. So before you go and buy a replacement charging port, be very observant and understand which kind of charging port you are looking for. Because if you just buy any charging port, they are not the same. The charging ports are not the same. As much as they are 5-pin charging ports, please understand. You know that, I believe you know that. They are not the same. I will repeat. These are two charging plates, and this is how they appear. These are two charging plates. I don't know if you can see them clearly. These are two charging plates, these ones. I don't know if you can see them clearly. Now I will place them under the microscope so that you can see them well. You see this is the upper part for one, and this is the upper part for the other. They are all 5-pin charging ports. 1, 2, 3, 4, 5. the same as the other one here. You can see 5-pin charging port, 1, 2, 3, 4, 5. If you remove this charging port and put it here, if you remove this one and put it here, the phone will not charge because you have reversed the polarity. One, the positive is on the left, another the positive is on the right. Because as I've said, you can look at that tank that takes in the charger. This one is on the upper side, and this other one is on the lower side. That is one mistake that common technicians that are not used to this field do make. Someone says that they just went to replace the charging port and the phone still did not work, even though the customer came in with the charging port that was loose, though it was working. So I replaced with another charging port and it did not work. That is one of the mistakes that most common technicians that are not used to this field do commit. So avoid that, or be very careful while handling such. We have the charging port here. We want to measure it, and we will see the difference of what I am talking about. These are just basic principles that you should be accustomed to and understand the ways of mobile repair. Please take your meter. I want you to measure something. You have a meter here. I want you to measure something, and please be keen on the buzzer because we're not going to show a meter reading. For physical lessons, please come to our workplace. We will teach you how to handle that. This is just a very basic principle that you should understand. Continuity mode on the meter, because you want to find out which part is negative on this plate. Continuity mode on the meter. Please work while it is under the microscope, because this is just a lesson. I don't know if you can see it where this. Okay. Costly because you just end up buying a whole complete plate, even though you can just fix that one. Unaona vizuri? Kama unaona vizuri, nataka uoshe hii plate. Ioshe. Hapa ndio tuone kile tunafanya. Osha kidogo tu. Nataka uone difference, the positive terminal and the negative polarity. So I want to show the difference. We are here, and I'm just going to explain to as far as this one is concerned, this charging port is concerned. After that one, you'll have the power will move from the charging port to the flex to the motherboard, and that is where now you'll have just to subscribe to our channel or pay for that knowledge. These are just common knowledge that I'm giving out for free. Now observe using this one. Be comfortable using the positive probe as the base. I want you to find me the ground terminal. Now let me explain to you something. You know last time why we were failing on getting the 5 volts voltage? Because you're using the port. This one is okay because it's already attached to the board. So most likely just ignore the port, ignore using this one as the base, unless the port is linked or connected to the motherboard. So what are you going to do here? It will work, yes, for this time, you can. But if you're measuring the port on itself, make sure you're using the end-to-end polarities. Push it further in. Should not get out of coverage. The lens is very, very dirty. The lens is very, very dirty. Very dirty. I don't know, it should be cleaned. I don't know if it is visible. What I'm saying is use this one as the ground for the positive probe. Now get me the ground for this 1, 2, 3, 4, 5. One of the pins is ground. Which pin is that? Yes. And the positive one? Pardon? Please repeat again. How do you place your probe? Look, how do you place your probe? Place it away like this one. This pin should be here. If you put it like this one, there is a probability that the probe is going to touch the negative. Okay. the base of the shield of the charging port. So you read it as ground. You see now the difference. There's a difference.
Yes.
From first time that you tested it, it was beeping
It is
because you were linking it to a wrong pin or a wrong shield. Now this, if you observe well, if you do your observation clearly, you'll understand that this part here is bold and big.
yes.
It's bold and bigger than this one, than this one, than this one. Then we have the negative one. The negative one, of course, it's the ground. All of this is grounded. You can
Yes.
see. But with this line here, there is like a drawing here. This one is big because it carries too much volts. Carries a lot of voltage. That is 5 volts. So here enters 5 volts. Now automatically, if you are used to such like principles, you will understand that this one, because of its size, carries much voltage. The same will apply while we are dealing with motherboards. You will see that some parts that are bigger and wider, they do carry a lot of voltages. Unlike the smaller, thinner ones, they do not carry a lot of voltages. You understand? So these are just principles that we are moving forward while we learn. So this is the positive side. You have found out that. Please place your probe so that we can verify that this is the negative side. Do not attach it to, yeah. You know, if you bring it too close, you're going to attach it to this one.
Yes.
And you'll hear the beep.
Yes.
And it will give you a wrong information. Now, place your probe like this, away like this. Do not touch here. You are touching here. Here, I just want you to touch this pin alone. That probe is very sharp and it should give you the correct value. Yeah, like that. So be very careful. If you attach it to this one, you're just going to get a wrong reading. You understand? That is how we do measure. Point at a point. You see, now we have the positive side on the right hand side.
Yes.
Now we'll be getting 5 volts here.
Yes.
If we place our charger and use the multimeter to measure, we'll be getting 5 volts here on the right hand side. Is okay?
Yes.
Try the other charging place so that you can understand the difference. Try the other charging plate that I just given to you. Put this on a side. We have understood that on the right hand side is the positive probe.
Yes.
The negative is the far left.
Yeah.
Try using that other charging plate. Yeah, like that. Push it closer inside the vicinity. Yeah, like that one. Remember what I told you, I have told you before concerning a thicker line.
Yeah.
You see? Now with this one, without measuring, which one is the positive side? Without measuring.
Without measuring.
Without even using the multimeter, which one is the positive side?
The left side.
Yeah, because you can see it already.
Yes.
This one is thicker. This is a trick that too many technicians do not understand. Even on motherboards, this part, if it is wider, of course the ground will be too wide, but this one, if it is wider than the rest, the adjacent ones, that is definitely the positive line. Now use the multimeter to prove or verify whatever you are saying. Put the red probe on the ground there. Remember, I have told you, do not put it on a slanty position. It is going to attach to something that you don't need it to. Put it on a straight, okay, comfortably put it on. I want you to measure this pin.
Let me put here.
Okay. You can start either way. Measure the far end here. Here. Put your probe there. You see? Next, like that one. While you move, until you find the ground. Those are just D minus and D plus. Now we have the ground on the far opposite left. Remember, the first charging plate, positive was on this side, on the right hand. Now this one, the positive is on. That's a trick that too many techs do not know. So while going to purchase a charging port, make sure you have a sample of the original charging port. Do not throw it away if you have not replaced it already, because you might end up mixing the charging ports and it will give you a hard time. Otherwise, if you understand these principles, it will be so easy for you, because you can modify any charging port and it will work. So you can even use a type C here, it will work. You can modify, it's very easy. Yeah, most people do not know, but that is just the way through. master this. Observe the points. The thicker one most likely carries a lot of voltage, but the ground one, it will just be visible because it is all spread through. So if you're missing these pins 1, 2, 3, the phone will still charge because we have the positive line and the far end is the negative. The negative line, you can link it to this ground, you can link it to this connector, you can link it to any other section that is grounded. But as for the positive line, after here, where does it go? We have already finished on observation of the charging port. Now you know how a charging port looks like. Let us now find the voltage before we move to where it goes to. We have charging. Okay. Let us try this one. Yeah, we have a charging cable there. We have a cable there with us. Now let us see about the voltage. The same, we will measure this one, we will measure the other one.
Okay.
Let us see about the voltage. Very good. With voltage measuring, the ground probe, the black probe is ground and the red probe is the one that we look for value with. But in continuity measuring, remember the red probe is the ground. That is just something that you will have to understand. Now we are here at 5 volts.
Yes.
I want to show you the difference. You see, we have positive 5 volts, and the positive side is on the left hand side.
Yes.
The positive side is, please interchange it like this one, so you can see it here like this. Now measure the positive side. Very good. Very good. We have the 5 volts there. This is the positive side, it's on your right.
Yes.
You can see. Let us measure the other one. With this one, you can see we are changing the direction of the charger.
Yes.
And like this one, it was entering like this one. So we are changing. If we change the direction of the charger, most probably the polarity will change. Measure this one. Remember, the polarity will change. So it will be on the opposite direction. It will be on the opposite side or opposite direction. It should give you 5 volts. It should give you a stable 5 volts, not unless there is a problem with the port itself. There is a problem with the port, but it should give you 5 volts. So this port just needs to be changed. Let us move forward. We are tracing goes. Where does the voltage goes from there? Now, what are we going to use to test? Continuity mode. Continuity mode. Please turn your knob to continuity mode and observe the lines. Where are we? We are here. Okay, now let us use this one as our case study. Flip over the charging plate, flip it over, geuza, and move it down a little, there, up a little more. We have this one as our positive side. I want you to trace this line. Trace this line to the charging connector, or to the next component, the immediate next component. After this one, trace it to the immediate next component. You are going to use continuity mode. after voltage coming in here, the current coming in here, where does it go? Where does it go? Where does it go? From there. From there, where does it go? Use all skills that you know, all skills that you acquired or have to show me the next point after that one. So how do you trace that one? It is not a must now to put it under the microscope. Now we are learning. The rest can come and learn in class. Where does it go? After that one, using continuity mode. Where does that pin go to? You have all the tools necessary. You have the microscope. If you want Borneo schematics, ask for it. I want you to show me using the multimeter. Okay, we understand continuity mode. You understand continuity mode?
Yes.
Continuity mode is where a circuit is complete. There is no breakage in between. So you will hear the buzzer, you'll just see the multimeter lighting up. Not unless it's a short. But on a normal charging plate or a normal circuit, where you get value one end to the other, continuity mode is a complete cycle. So how do you find a complete cycle? By attaching one probe from the point that you want to start with by attaching one probe from the point that you want to start from, and the next probe is used to find the next line or the next target or the next point that you want to find whether it's complete. Use all the information that you have, all the knowledge that you have to show me this is the point that is connected to the positive side of the charging port, because you have been through this and we are doing revision, and I want to see whether you know something. Use all the knowledge that you have. I have said you can even ask for Borneo schematics. I will give it to you. You can use the microscope. You can use any skill that you want, but just prove to me. You might be knowing, yes, but prove to me after this point, the next point that the current will move is this one. Show me by use of a multimeter. That's the professional way. I want you to show me. You've taken more than 10 minutes now. Show me. You already know where the positive terminal is here. Which one is the positive one?
This one.
Now, I want to show me after here, where does current move? Oh, where does that line move? From there. How does power move from there to?
Inaenda hivi.
Use the multimeter. Show me. Continuity mode. Usiogope, kuna kuchapwa. Kuna kuchapwa. Ni kuelewa. Kenya nataka ni uelewe. What I want you to do is understand. Understand and not cram. So that if you meet a stranger device that you're not used to, it will not be a task for you to fix it or to find out whatever you're looking for. After you've just understood the basic principles of how to move around with the continuity or the multimeter, it will be so easy for you. Very easy. Now let me show you maybe.
Yes.
Let me show you. I think it's becoming harder. So we are here. And we already know the positive terminal.
Yes.
So you place your there. Or if this one is for practice purposes, if you don't find it easier, let me show you. I've told you, ask me for any tool that you want. any tool that you want, any. And you're not asking me for anything. You could even have asked for Bonnet schematics because Bonnet already showed the way. You see here, scratch a little. You should not always be scratching. I just want to show you how this moves. You can use this one as a pin to find out where the next. This is the positive line. Let me not even scratch it. You place your probe here. You place your probe. Look, observe. Place your probe here and hold the plate. Place your probe here. Hold the plate and use this one to find whether you're shorting, you're not shorting, and try to find the pins. This is the origin.
Yes.
Where does it move next? You can see. Make sure it is attached to the point where we want to have it as a reference point, and try to find the location where power will move to. Now you have already found it is this one. You are showing me, right? Yes, but prove it. How will you to explain to someone, you know, you're showing me it is moving here because you already know this component is for charging. Now it is easy for you.
Yeah.
But what of someone that is not used to that knowledge? You place one probe on the right and use the other one to find the next movement, because it does not come here always at all times first. It might enter a capacitor, it might enter other components, small components. So this is how we look for continuity, by testing single components. You see, so it is coming here, it is coming here to the cap, then to the diode. You know what is the work of a capacitor? What is the work of a cap?
Capacitor.
Yes,
Filtrate there.
you did basic electronics. What is the work of a capacitor?
Store charge.
You don't just say to store charge, because if you say to store charge, there is no difference between a capacitor and a battery. Yet there are differences. A capacitor is like a battery, but they are different. A complete explanation of a capacitor is
Stores charge for short term uses.
yeah, that one is better. It stores charge for a shorter period of time, and it helps in smoothing the flow of charge or current. We're here. So after 5 volts coming from there, 5 volts will enter here. So that it can be stable, 5 volts will enter the cap, and after the cap it will go into the what is the work of a diode?
Diode here.
Yeah, basic electronics. What's the work of a diode?
It facilitates current to flow in one direction.
Exactly. Tutarudia basic electronics. Napoteza vitu ama mfanye revision. So after coming here, now let us take it back there. So we can have a clear presentation or an explanation of what usually goes on. Now we are here. Remember, the charging plate has so many sections, but ignore the rest. We are on the charging line only, because you can see here there are network filters. This one is a network connector. This one is a network extension antenna. You have seen that. Please measure here on continuity mode. Measure this point, and this point. These 3 adjacent points. Measure them. I want to see if they are connected.
Which point?
Measure this one. Put one probe here.
One probe.
Here. Yeah. The next one immediately to the capacitor. Not on the opposite side. Here. There. And there. Put it here too. Here. The first filter here. Here. The second one. Here. Put it here. I'll just explain to you how to measure those components. Not the opposite, exactly there. You see, with observation, you will find out that this whole path will have 5 volts. You understand? Remove the probe. You'll understand this whole path here will have 5 volts. And you can see here there is a cap. What is the work of a capacitor?
To store
Do not forget.
yeah.
Do not forget. It should be easier for you to explain because maybe you already understand what is the work of a cap because power is coming here. There is current that is entering here. What is the work of a capacitor?
Store the charges, how the current.
Nimesema, okay, I have said that you should give a complete explanation, not a half one. What is the work of a capacitor? Dan, repeat what is the work of a cap.
To charge for short period of time.
Yeah, a capacitor stores charge for a short period of time. That is true. It stores and releases. But the main thing that I'm looking for here, the main explanation is it smoothens the flow of current. It will smoothen the flow of current from the port here to the diode. You understand? We will explain. I will have to explain this one a little. Or we will deal this one with basic electronics. Because if I start explaining our capacitor, that's another subject. We'll deal with that one with basic electronics. Now you have understood from 240 to 5. From 5, from the port, it enters here, here, and here, then to the connector. Now I want you to find me the positive side. This is the positive one, the one that is carrying the current. From here to the connector.